equilibrium situation for two-body system. A donkey pulls a cart at a uniform velocity of 2 meters per second. The mass of the donkey is 200 kilograms, while the mass of the cart with the driver is 70 kilograms. The donkey applies a force of 1000 newtons to the right. The ratio of the frictional forces on the donkey and the cart with the driver is the same as the ratio of their masses. Assume that the mass of the shaft is negligible. Calculate the magnitude and direction of the total frictional force present, the magnitude of the tension in the shaft. Solution. Before we proceed, let us identify the situation. The surface is horizontal. It is a rough surface. The donkey-cart system is in equilibrium state since it is moving at constant velocity. In this problem, we consider the donkey-cart as a system consisting of two bodies, one, the donkey, and the other, the cart with the driver. Let us find the forces acting on the donkey and the cart with the driver and draw their free body diagrams. For the donkey, the force of gravity is Fgd, is acting the downward direction. The normal force acts perpendicular to the surface. The plane of motion is along the horizontal surface, so the net force in a direction perpendicular to the plane is 0. A force F is applied on the donkey towards the right. This is balanced by the frictional force on the donkey and the tension in the shaft. That completes our free body diagram for the donkey. Let us now consider the cart and driver, which is one body. For the cart with driver, the force of gravity, Fgc, is acting in the downward direction. The normal force acts perpendicular to the surface. The plane of motion is along the horizontal surface. So, the net force in a direction perpendicular to the plane is 0. For the cart with driver, the tension in the shaft, Tc, is acting towards the right. There is a frictional force, Fc, acting towards the left. These two forces are balanced since the cart with driver is also moving at constant velocity. That completes our free body diagram for the cart with driver. We can apply Newton's second law to the motion of the donkey. Vector Fr dx equals m vector a dx. Vector Fr dx is the vector sum of the forces on the donkey along the horizontal plane. Therefore, vector Fr dx equals vector F applied plus vector Fd plus vector Td. Taking the direction towards the right as positive, we get vector F r dx equals F applied minus Fd minus Td. Combining 1 and 2, we get m vector a dx equals F applied minus Fd minus Td. Here, the acceleration is 0 since the donkey is in equilibrium state, that is uniform motion. 0 equals F applied minus Fd minus Td. Substituting the values, we get 0 equals 1000 minus Fd minus Td. We can also apply Newton's second law to the motion of the cart with driver, the second body. Vector Frcx equals m vector acx. Vector Frcx is the vector sum of the forces along the horizontal plane. Therefore, vector Frcx equals vector Tc plus vector Fc. Taking the direction towards the right as positive, we get vector Frcx equals Tc minus Fc. Combining 4 and 5, we get m vector acx equals Tc minus Fc. Here, the acceleration is 0, since the cart with the driver is also in equilibrium state, that is uniform motion. 0 equals Tc minus Fc. The tension in the shaft at the two ends will be the same as it is the same shaft. Therefore, Tc equals Td equals T. Combining this equation with 3 and 6, we get T equals Fc. Fd plus T equals 1000. Combining 7 and 8, we get Fd plus Fc equals 1000. Therefore, the total frictional force equals 1000 newtons, and it is directed towards the left. We are also given that the ratio of the frictional forces on the donkey and the cart with the driver is the same as the ratio of their masses. Fc over Fd equals 70 over 200. Adding 1 to both sides, Fc over Fd plus 1 equals 70 over 200 plus 1. Fc plus Fd over Fd equals 270 over 200. Or Fd over FC plus FD equals 200 over 270. FC plus FD is the total friction on the system, which is given as 1000 newtons. Therefore, FD equals 200 over 270 times 1000 equals 740,7 newtons. FC equals 1000 minus 740,7 equals 259,3 newtons. Substituting in 7, the tension in the shaft, T, equals FC equals 259,3 newtons.
Starting to feel it? Now go master it with Maski.